Today's video is sponsored by Native Sons Goods, makers of premium quality guitar, bag, and camera straps, handmade in Albuquerque, New Mexico. Check out their website to order your own custom creation and play in style. And remember, when you support my sponsors, you support this channel, and I sure appreciate it. Hey, what's up guys and gals? Brad the Guitarologist here. We are going to service this recorder for studio preamp use. If that sounds like something you'd be interested in, please stick around. Before we get inside the case, I want to show you the rear of this thing. On the back here we have a little nameplate with Ampex stereo written on it and Sunnyvale, California. The model number is a 601 and there's a serial number there as well, serial number 1200 in this case. There's a catalog number there as well, which I'm not sure why that would be. Over here we can see there's been some work done to this. It has had a power socket installed in place of the old socket. This one is a 3-prong. So that's some of our work done for us already. We have a 1/4 inch output here. We also have another output here, input labeled line input. And the top on this thing just basically pops off. You have places here for additional spools. And here's the inside of the unit. You can see here's where our spools go, and this should accommodate up to 7.5 inch reels. We have controls here for play and record, rewind and fast forward. Our heads are underneath here. We have a really cool little VU meter here, which I like quite a lot. Looks pretty cool. We have controls down here for the microphone record level, the monitor selector, whether we want to monitor the input or the tape. We have a line record level here. This obviously does what it says what it does. What we're going to do is just generally service it. The customer that brought it to me says when he tries to use it, it will do okay for a little bit, and then all sound just kind of drops completely out. And then I can't remember if he said if it comes back or not eventually, but the fact that we've got sound that just drops out after a little while tells me we could have a couple of different issues. We could have issue with parasitic oscillation. We could have a bad tube. We could have issues with capacitors that are faulty, that are at higher voltages, and when they warm up, they could be over biasing a tube. So, we need to get in here and figure out what's going on. Okay, we have several screws here along the sides. I think these come out in sections. So I think this amplifier section down here comes out separately from this section up here, but we'll see. These are known for having pretty good preamps. Okay, we do have a cable here which is separated. And I think it was separated intentionally because he's not using this upper portion, and this cable is what connects the two. Here's a look at the guts. We have a 12AY7 here, 12AU, a couple of 12AUs. This is a 6267, which that's an EF86, and that's a real nice tube. Look at that. There's an Ampex Bugle Boy. That's a Made in England Bugle Boy. So that would be a Mullard EF86. This would have been the exact same type of tube that you would have found in early Vox AC15s or AC30s. 939. So this would be 1959, the 39th week. Cool tube. Now these have a tendency to be microphonic sometimes because they are pentodes. So we'll look into that and make sure that that's not a contributing factor. We have some controls here on the back. In addition to a 1 amp fuse, which we will check momentarily, we have a hum balance pot over here, and we'll of course set that. We have a bias pot here. There's another 12AU7 hiding up here on the front. There's also a noise balance pot hiding down in there. And there's no output tube on this. This is just a preamp. We have a record calibration here, which probably calibrates the head bias, I would imagine.
Actually, as we shall later see, this acts more like a secondary gain control.
PB level. Not sure what that is. PB equal.
These are level and equalizer controls for the playback.
Let's get the schematic out and see what we have here, and then we'll open up this thing and see what kind of caps and everything are in here. Well, you really got to love the internet. After searching for all of 30 seconds online, I found the original Ampex Model 601 operation and maintenance manual. This thing's dated October 1958. Okay, the recording inputs here. It accommodates any high impedance microphone and can be quickly converted for a low impedance microphone with a plug-in accessory transformer, which this actually already has. HS273P input transformer. This thing is just chock full of information that's really not needed, including information on how magnetic tape works. I mean, it's got the whole shebang. Interesting stuff. They really didn't skimp on their reading materials back in the day, man. It even gives you a formula for calculating the voltage induced across the head. Why you would ever need that, I have no clue. Okay, so the output apparently is a 3-circuit balanced. So it's a 3-terminal balance, but it doesn't look like it because it's just a 1/4 inch. So you'll use like a stereo 1/4 inch output, and if you want to, you can. The other end can be a XLR type connector. Yeah, so it can work balanced or unbalanced. Here's the whole damn mechanism. Every single part in the mechanism exploded out. That's awesome. It's like servicing an automobile. Yeah, man, you just don't see this level of support from companies anymore. You just don't. I mean, this is to get something like this on a piece of modern equipment is really unheard of. Okay, here we go. Electronic assembly. The electronic assembly consists of a record channel, a reproduce channel, a bias and erase oscillator, and a power supply mounted on a single chassis. We will not use the bias and erase oscillator, obviously. We may even be able to remove its tube with no ill effects. This says we should have 2 EF86s in here, V101 and V105. This may be somewhat hard to read because I'm on a computer and we're looking at the computer screen here. At any rate, here's our microphone input. Here's our first stage, which is a EF86. Great sounding tube. Pintos just tend to bring out a lot of clarity, more crisp highs. We're going to go through and check all of these capacitors in the signal path particularly. We're going to check all these, check all of the plate resistors, make sure none of those are severely drifted or burned. Okay, here's our second channel down here. This is the playback head. So the signal from the playback head goes into this 6F5 triode. That's the octal tube that has the cap on top. Then it goes into another EF86, which is in the second stage on this one. We can see the line input down here. This is showing just 2 conductors here. This line input goes through 250K pot. That'll be the pot on the front, the control pot, and then it comes into this 12AY7, and the signal comes through here, goes through a recording equal. This is an adjustable capacitor. Here's the main power section down here. So it looks like we have 1, 2, 3, 4 main capacitors we'll have to look at. We'll check out these resistors as well, make sure none of those is faulty. We do have a hum balance pot we will go ahead and set. Alright, I'll tell you what let's do right now. Let's go ahead and open this thing up, check out the capacitors we're going to need to replace. Go ahead and replace those. We'll definitely do the electrolytics and get those out of the way, and then we will check some of these other signal capacitors. We'll definitely check C102, 104, 106, 110, 112. We'll check all of those to make sure those are all good, and once again we'll also check these plate resistors, make sure those are good. And if signal's kind of dropping out after a while, I can't imagine that one of those things would not be at fault. Alright, before I do anything at all, I think I want to plug this thing in and bring it up on the Variac and see if we can get some sound out of it through my little test amp back here. And then also see if we can reproduce the problem. Alright, so let's plug a microphone in. Check, check. Whoa, check, 1, 2, check. Check, 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 check. Check, check. Okay, the tape, that's, obviously we need to use the input. Check, 1, 2, check, test, test, test. Let's see. Check 1, check 1, check, pop, 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 pop. Check. Check 1. Dang. Check 1. Hell's bells. Check 1, 2, check. Check 1, 2. Very, very, very sensitive. Very sensitive. Let's see. Let's go ahead and set the hum balance on this thing. Because since we can, I'm just going to take note of where it is at the moment. It was perfectly set already. Okay, let's see. Record calibration. What was the PB level? Oh, that's playback. Playback level and playback equalization. Okay, so that has nothing to do with the line input. Okay. Okay, so the bias and record calibration we will do nothing with. Playback level, playback EQ we will do nothing with. Hum balance is set, so those are good. Okay, so the noise balance control is in the record circuit. V107 we should be able to pull. Let's see, V107. Where's 107? It will be a 12AU7. Which one is it? It doesn't label them. It's given me virtually everything else, but it doesn't label that. I'm going to go out on a limb and I'm going to guess this one is V107. And it's going to have no bearing on the function of this thing as a preamp. Check 1, 2. And that is correct. Okay, so this can be stashed away and used as a spare in the future. That's a, you know, it's an RCA 12AU7. There's no sense in having that burning if it's not in use. It just doesn't make any sense to do that. So we'll set that aside. We'll set this aside too. Okay, let's see if there are any other tubes. There should be other tubes that you could actually pull with no ill effects. You should be able to pull V104, this one. Should be able to pull this tube. V105, this one. You could definitely take those two out. As a matter of fact, I'm going to go ahead and pull both. Let's see, wait. Which one is the cap? Let's see, this is a 6F5, so I want to make sure there's no plate voltage or anything on that cap. It should be the grid. Yes, that's the grid. Okay, so this tube can be pulled because it's in the other channel. Check 1 2, check 1 2, check check check, test 1 2. The good thing about pulling these tubes is that it's going to save them for future use. You won't have these burning, you know, every time the thing comes on. Particularly this one, because this is an EF. This is another EF86 tube, and there's just no point in burning this tube every time you have this unit on if you're only using that other channel. It doesn't make any sense to do that. So what he's going to end up with is a kind of a stash of a couple of replacement tubes for this thing. Okay, I've just been speaking into this microphone because I'm trying to make it reproduce the problem, and so far I've been unsuccessful in reproducing the problem. Tell you what I can go ahead and do. Check check check. See, yeah, that's the channel. I can go ahead and clean some sockets here. Checking 1, checking 1. Check in 1 2 3. Check 2 3. I'm starting to get some rustling in the background now. Okay, pulling that tube right there made the rustling disappear. So whatever it is, the 12AY7, whatever stage that is. Nope. No, the rustling. Interesting. Man, that tube is hot. That tube right there is hotter than hell. I wonder why. Yeah, preamp tube shouldn't really be all that hot. That's hot. I think this thing might be I think the bias might be off on this. But yeah, I'm starting to get a lot more noise now. And you can probably hear that. You know, I don't think this thing has any problem with the electrolytics. All right, so I was kind of screwing around with this thing, and I noticed that when I pulled this tube right here, the sound kind of cut out. Well, it didn't cut out completely, but it started wailing at me. When I pulled this tube, the sound does cut out completely. It kind of puzzled me that that was happening, and then I looked again at the schematic. If we look at the schematic here, sorry if we can't see this very clearly, but we can see coming off of this tube here, we have 250K record calibration pot. Okay, so the signal comes down here, and when the selector switch on the front labeled input is selected, which is what we have selected, then it goes through this final two stages here to the little output transformer, and then to the output. You have some headphones here as well, pre-transformer. That's why pulling this tube right here shuts it up completely, and pulling the other tube seems to give it some wail. It just starts to howl at me, and I think that would have been this tube, because without this tube being in operation, it's probably throwing off the impedance or something a bit further back at this point, so it's causing it to just howl and distort. But what I did notice was this: when I turn this record calibration pot, it appears to be extremely dirty. Check, check, check. That is right in the signal path. And this might be the first time in its entire life it's ever been turned, so that could definitely be the source of the problem. Okay, after sort of turning this record calibration pot back and forth, not only has the little dropouts I was hearing gone away, but also the rustling of leaves has gone away too, which was kind of getting louder as the thing seemed to be as it warmed up. But it also sounds like it may have some leaking DC on that too, so that would be coming from that previous stage's capacitor. So let's go ahead and check some capacitors and go from there. Alright, here's the bottom of the unit. The bottom plate is held on, looks like by 2 screws. Oh boy. Yep. There's definitely a reason why this thing is not operating optimally. Look at all these Bumblebee capacitors. These things are notorious for being bad. I mean, notorious. And I can probably even demonstrate that here in just a minute. We've got some little domino capacitors over here. Those are mica mold, I believe. Those are on the socket for the 12AU7 and the record bias circuit, so we probably won't change those. But most of the rest of these need to be changed. Okay, so the electrolytics, I mean, if I were to replace all of the electrolytics, the cans, that's really going to run up a bill. Because those, I mean, there's, in just this one can here, there's 4 10 microfarad capacitors. And it would be easiest just to replace the can, to measure the can and try to get a replacement. There's another electrolytic capacitor up here, but the biggest, I think the biggest thing that's going to make the difference is replacing these stupid Bumblebees over here. These are not good capacitors in an amplifier. They're just not. They cannot stand the voltages present. They don't hold up very well. And they just need to come out of here. Here's another electrolytic over here. So this thing's full of electrolytics, but this is a dry electrolytic. This is probably okay, actually. If electrolytic was really bad, you would know it. None of these resistors here look bad either. I mean, just because they don't look bad doesn't mean they're good, but they're not burned to a crisp or anything like that, these big power resistors. I'm kind of thinking we'll probably just start replacing these coupling caps over here and just wipe them all out. There's actually a couple of these that won't matter, because see, there are a couple of these that are connected on the playback. Here's a playback level, playback EQ, and we've got some capacitors going into those stages. So these capacitors right here could probably stay just because they're not going to be in use. I could probably also identify 1 or 2 others that won't be in use just because of the channel they're in. But we're going to replace all the coupling capacitors definitely in the microphone channel. I think just for demonstration purposes, I think I'd like to test some of these capacitors with this thing on. Start here. And what I'm going to do is just check the DC voltage on one side of the capacitor. Okay, right there it's 143 volts. And let's check it on the other side. 1.3 volts, 1.4 volts, which is really more than you want. You don't want anything, really. Ideally. Check this one. Whoop. 168 volts on that side. 9.6 volts on this other side, so that one's leaky as hell. This one. Okay, where are you? This one, 109 volts on that side. 2 volts on the other side of that one, so that one's bad also. But you see what I mean here. These are all going to be bad capacitors. It's got freaking 5 volts on it anyway. I'm going to go ahead and change it regardless. Even though there's no tube in that socket, I'm going to go ahead and change it. I'm going to do the same for this one too. Okay, this one's got 239 volts on one side of it. And 10.6 volts on the other side, so that one's terrible also. This one's got, let's see, nothing on that. What about this one? This is just a, yeah, that's a nothing, so that one can stay. That's just, okay, this big thing, 0.5 microfarad. That is a, I think that's some kind of bypass cap. I'm not sure. We do have a couple disc capacitors down there, but those can probably stay. I'm sure they're fine. But yeah, we definitely need to change all of these caps over here. Alright, we're back with this thing, and I have those capacitors all replaced over here. And we're ready to fire it up and see what it does or doesn't do. I think it's going to be a lot better off now. I did not replace this electrolytic. I did not replace this capacitor because both of those are in the playback channel. So those, you know, if there's no signal coming from the playback head, then these won't be used at all. This capacitor here is also in the playback channel. No, excuse me, this one is in the oscillator for the bias. So that is not necessary. But let's fire it up and see what it does. Testing 1, 2, 3. I'm also willing to bet that this is the issue here is completely, yeah. See, the issue there is completely gone. So there's no more DC on that pot. Perfect. Yeah, it's extremely quiet now. I don't think this thing needs electrolytics. I mean, this would probably, it would probably be fairly costly to change all 3 of these electrolytic cans. And there's so little room inside of here, I really wouldn't want to try to squeeze them all down in here. So I'm going to advise him for right now to hold off on the electrolytic cans because this thing is dead quiet. They seem to be just fine. And I think our problem lay pretty much exclusively with those crappy Bumblebee capacitors. Let's check these things out. I'm curious to see how bad they were on my meter. Alright, I'm curious how bad these capacitors that I took out of here actually were. Let's check them out. And this isn't going to be at the high voltage, but if they're bad at these lower voltages, you know they're bad at the higher voltage. Well, this one's 1% loss and 62 nanofarads, and that should be 47. So it's, that one's not too bad, but it is lossy. Let's check this one here. This one's supposed to be 1 microfarad, or excuse me, 0.1 microfarad. 2.3% loss. Look at the ESR, 16 ohm ESR. That's bad. And this is about twice the value that it should be. It should be 100 nanofarads, not 210. So that one's bad. The lossiness is the big issue. This one should also be a 0.47. So it's about double in value, and it's lossier than the last one, so that one's bad. This one should be a 0.1 microfarad capacitor also, or a 100 nanofarad. This is 189 nanofarad, higher ESR than any we've seen, and it's about as lossy as any we've seen. So these are just bad capacitors on the whole. This Sangamo right here might even be the worst of all. This one, let's see, I'm not sure if I can bite any metal on this one. I'll try. 3.5% loss, yep. That one's really bad. Okay, so to recap what was done, we changed some of the coupling capacitors in this thing. We also removed 3 of the tubes, and it does not need those to operate on the channel this customer wants this thing to operate on. So removing these tubes, what that's going to do is it's going to preserve them for another day. That way they can be used as replacements when these other ones go bad, because this would be a relatively expensive tube if you had to go out and buy it, you know, an RCA 12AU7. So I see no sense in just burning it up in a spot where it's not going to be used or heard, when you can just pluck it out of there. And especially this one, this EF86 right here, getting that one out of there and preserving it as a replacement, eventual replacement for this one, is a really wise move. This 12AU7 should run a lot cooler. It was running hot earlier, and there's a good reason for that. That was way off on the bias because of those leaky capacitors. So that solved that problem. The recording calibration adjustment on the back, that one was that pot had DC on it, so it was scratchy as hell. So we've rectified that situation. It's no longer scratchy. We set the hum balance, or we checked it, and it was fine. Let's see what else. That's pretty much it. So this thing is ready to go back to the customer, ready to be put back into service, and I believe he's going to get years of good use out of it still. And yeah, so that's all for this video. Hope you guys have enjoyed this one. Please hit subscribe down below if you have, and for now, y'all take care.